This video is for the Riemann sum example worksheet, which you see there on the screen. I'm going to do this one in Excel, not handwriting anything. So let's take a look at what we've got going on here. So it's helpful to identify these different parts here. So let's go back to Word. So it does say approximate the area in the interval. You're told the A and the B and the N. Sometimes the A and B might not be so obvious, like the next example we'll look at, or the exercise one. Okay, so the A, it says we start at 0, and B, we go to 600, 6 subintervals, and our delta x is always the B minus the A, all divided by that N, like that, which is pretty straight. You can do 600 minus 0 divided by 6 in your head, so no big deal. These are some of the things that you should write out. It's very helpful that when I grade it that I see that you identified A, B, N, and delta x correctly, because you get everything else wrong if you don't. Okay, now let's look at our x's. So actually I'm going to do my intervals, and I'm going 1 through 6. So I've only got 6 of my intervals there. And my x's, the first x is always the A value. You don't have to do cell reference for this, but it will always be the A value. The next x, you take the previous one and you add your delta x. So if you do a cell reference here, lock it in with the F4 key, or manually type those dollar signs, or just type plus 100. So it doesn't make any difference how you approach it. And then after you've got that, copy and paste. And remember, when you get to the last interval, it should be a single delta x less than your B. So my B is 600, my delta x is 100. The last thing that you use is going to be that 500 there. The next thing is going to be the f of x. So this is where we type in the formula that was given on that worksheet. So let's go back and look. 600x minus x squared. And some cell references here. And copy and paste. And this is, I think, some of the part where I differ from the lab manual. So I just go ahead and sum all of these up. And then I do my Riemann sum. Oops, there we go, right justified. So you add up all of the heights of the rectangle, and we're going to multiply it by the width. So there's all my heights, and my width is at 100. So I'm not going to use a cell reference, I'm just going to do that. So that would be my Riemann sum. And I'm going to put the commas in there because it helps me to see those commas. So 35 million is my Riemann sum. That's the part A. Let's take a look at the part B. So I'm going to copy, I'm not going to copy any of that because it'll just mess it up. Let's do this. So the only difference in part A and part B is part B is using 60 subintervals. Now that part A, you could theoretically do it by hand, but you can't do 60 by hand. That would take well too long. So still starting at 0, still going to 600, but 60 subintervals. And you can do 600 divided by 60. Your A value is not always going to be 0. So if it is a different number, make sure you do that arithmetic correctly. Right there is good. So, and I'm going to do this one differently so I don't have to type all 60 of those in. So your first x is always the A value. You don't have to use a cell reference. Your second x is always the previous x added to the delta x, and I didn't use a cell reference here so you could see the difference. And the formula is the same, so I'm going to go ahead and copy and paste it over here like that. And now what we're going to do is I'm going to highlight those, get the little plus, so the big plus right there, the crosshair plus, and then that little plus there, and then count it down, and it's automatically going to give me the 60, so I'm just counting to 60. Don't go too far. Oh, it disappeared. There we go. And I screwed it up. How did I screw it up? Let's try to figure out what is going on here. So I added the, there's my 0. I added L4 to that. Why? Because I'd copied that pattern. So this, I've seen this happen with students, and I deliberately did that. So let's delete that, and let's take this one and create that pattern. So now instead of having a fixed 0 at the beginning, I've got a formula in all of these. And I do need a 3 there to get that pattern. Now you can copy and paste however you want to. Remember, that's up to you. I'm just trying to show you this drag and drop here. You can do Control C and then can highlight where you want it and Control V. There's many different ways of copying and pasting. This is just one, but be aware of the mistakes that could happen when you do that. That was one that I just illustrated, and hopefully I don't get another one. So think about how your x's progress. They start at 0 and they increase by 10 each time. So it's real easy to check this one. If it's a decimal, it's hard to see like that. And we want to get to the bottom here. You don't have to do it at the bottom. You can do it at the top. Let's do it at the top so we can see them together. So I'm going to do my sum of f of x right there, and then my Riemann. I'm just going to abbreviate right there on the left. So equals the sum of my f's right there. And then my Riemann sum is going to be that times the 10, the delta x, like that. Put some commas in there so I can see how it looks. And there we go. So our first answer for part A was 35 million. Our second answer for part B was a little bit more, almost 36 million. One other thing, so we definitely, when we answer this, want the Riemann sum. Probably want to write down as much information as you can, and you will be asked specifically for a few of your entries at the beginning. So these are basically the things that you'd probably want to write down. So the A, B, N, and delta are good things. Probably the first 3 of these are good, and then those 2 things at the end, your sum and your Riemann sum, and that will help in the grading, because if you just write the Riemann sum down and nothing else, and it's wrong, you hadn't shown your work, no partial credit, you get the idea like that. So you may even want to write down the formula just in case. I don't know, there's things. We've talked about that in class. Okay, so that's the example 1. Let's turn the page over. But before we turn the page, let's see how my editing skills work out, because I forgot part C, didn't I? The thing that we want to do now is speculate about that limit. So let's go back and take a look at that. So based on these 2 answers, speculate the limit as n. Remember, n is the number of, n is or are the number of rectangles. So as the number of rectangles gets larger, so we went from 6 to 60, and you could easily do 600. It wouldn't take you a couple of minutes. But when we had 6 of those subintervals, 6 rectangles, 35 million. Oh, what's going on there? And when we had 60, we had 35,990,000. So does that look like it's getting close to something to you? It does to me. How about 36 million? I think if we did 600, we'd probably be even closer to 36 million. So well, that's a connection to something that we're going to do in the future when we go back to actually doing the calculus, the antiderivative. We're going to have the start and stop values, and that's just how it relates.